And let's take a look at that. See, everything is made up of individual quanta, we discover. If I take a line, and I could obviously cut it in half and throw half of that other half away, I have now half that line. I can do the same thing again. Whatever I've got left, I can cut in half, and I can keep doing this, right? You would think, at least conceptually, I could do that forever. It turns out not to be true. When I get down to 10 to the minus 33 centimeters, I find a very embarrassing discovery. I discover that if I cut that in half, it suddenly is everywhere at the same time. It loses a property that the physicists called locality. It loses locality. They now have been able to prove that every photon in the universe knows what every other photon is doing. They're somehow connected. And that's bizarre. It's so bizarre that Boltzmann, one of the early quantum physics discoverers, committed suicide. He couldn't handle it. He understood the implications of that. There is a Planck length of 10 to the 33 centimeters, a Planck time. There is no period of time shorter than 10 to the minus 43 seconds. Everything we know, length, mass, energy, time, are all made up of indivisible units. That's why they call it quanta. They call them quanta, and that's why they call this field of study quantum physics. Let's just talk of constants here. I want to share something else that I think you'll find provocative. There are all kinds of constants in physics. You know, how many pounds to the meter, whatever. All kinds of constants. Most measures in physics have dimensions of pounds or length or energy or time. There are some ratios that are dimensionless. They hold true no matter what units you happen to be using to measure. Example, there are two dimensionless constants in the universe. One is called pi. All of us have experienced that in school, the ratio of a diameter to the circumference of a circle. Doesn't matter whether it's in inches or miles or light years. The other dimensionless constant is one that you probably have not run into unless you've taken a course in calculus or advanced engineering. It's a very peculiar number. It's the base of natural logarithms, called E. E is just as well known to an engineer or an advanced mathematician as pi is to most of us. But they're both dimensionless constants. There are also two key verses in the Bible about creation. Genesis 1:1, of course, in the beginning God created the heaven and the earth, and John 1:1, in the beginning was the Word, and so forth. Genesis 1:1 and John 1:1. Two dimensionless constants, two key verses. Let's take a look at this verse. It opens the Bible, Genesis 1:1. 7 words, 28 letters. And of course it goes from right to left, being in Hebrew. If you take, and of course Greek and Hebrew, the two key languages of the Bible, both have the unique characteristic that each of the letters has a numerical value. In the Roman alphabet, 6 of them do, not all of them. Have you ever tried to do arithmetic with Roman letters? That's another little exercise. But in Hebrew and Greek, each letter has a numerical value, which means each word has a numerical value. If you take the number of letters and the product times the product of the letters, and you divide that by the number of words, the product of the words, strangely, you get pi to 4 decimal places, 3.1416. Now, most of us recognize that number from school, 3.14159, whatever. Some have just used 22/7 as an approximation, but that's pi. To 4 decimal places, that's pretty impressive. You figure, well, that's just a curiosity somehow. Maybe that's fine. That's pi, of course. John Napier, who lived died in the 17th century. He happened to be an activist for the Reformation, by the way. But he also is well known in the field of mathematics as the discoverer of logarithms. In fact, the natural logarithm, as it's called, is often called the Napierian logarithm. That's the log to the base e. It has some peculiar characteristics that prove to be very valuable, very useful in advanced mathematics. So e is a very key number. He's also the one that first used decimal points in fractions. So e in mathematics is the number most commonly defined by a limit of an expression that becomes large without bound. The limiting value of e is 2.71828188285, and on it goes. It's another one of these strange numbers that you encounter in advanced math. The number e forms the base of a natural logarithm. Now, it appears as an exponential function having the rate of growth equal to its size. In the language of calculus, it's the only function having a derivative equal to itself. But be that as it may, that causes it to appear everywhere in mathematics. It's a necessary component in curves like a catenary. It's the study in imaginary numbers that go on and on and on. It appears constantly in the theory of probability, and I won't bore you with all of that. It's a number. It appears in formulas calculating compound interest. If you go through theory of numbers, E crops up. It's the number of prime numbers, the first n numbers if n is extremely large. In wave mechanics, it shows up. In electrical theory, it shows up. In advanced math, it shows up. In distribution of prime numbers. All these equations occur in almost every field of study. In the advanced math, you stumble into this strange number called E. So, and it's usually approximated, as I say, 2.7183, we call it. Well, let's take the other verse that we talked about in creation, John 1:1. In the beginning was the Word was with God, the Word was God. Take that in the Greek and do exactly the same thing that we did with the Hebrew of Genesis 1. The number of letters times the product of letters, the number of words times the product of words. And guess what? You get E to 4 decimal places. I was given this paper when I was in Europe, and I thought it was just one of these, I get a lot of things handed to me, pretty strange stuff. But on the way back, I actually was so intrigued with it, I actually wrote a computer program to check it. And I used my computer. And it turns out, much to my amazement, it's true that if you do that with Genesis 1:1, you get pi to 4 decimal places. If you do that to John 1:1, you get E to 4 decimal places. That's precise. That's an astonishing level of precision. And this is fascinating to me because, when you travel among some of the scholars, you discover that there are Hebrew scholars that believe not only did God create the universe, of course, but that the Torah was the template by which he did it. And you encounter those ideas and you smile as the colorful exaggerations. Until you stumble into something like this, then you begin to suspect just maybe the rabbis were closer to the truth than we gave them credit for. The non-constancy of constants. It turns out that Scientific American in June of 2005 had an article that expressed the concern by many scientists that the constants of physics they're beginning to suspect are not constant at all, that they're subtly changing slightly. And that's caused great concern, all kinds of experiments to try to confirm that constants are indeed really constant. What's fascinating about that, the reason I make reference to it, these are Scientific American words, not mine. If indeed the constants are proved not to be quite constant, and by the way, Einstein, when he talked about light, he regarded light as a constant, but he admitted he would be surprised if there was anything constant in the universe. Everything's relative in his mind. According to these articles in Scientific American, if the constants are changing, that implies that our reality that we take for granted is but a shadow of a larger reality. They're words. And that's what the Bible's been saying all along. Hebrews 11:3 we looked at before. 1 Corinthians 15 deals with this. All through the Scripture, we speak of the physical world as a subset of something larger. For lack of a better term, we think of as the spiritual world. The spiritual world is the real one. The one we're in is like a virtual game that we're playing. We're virtual people in a virtual environment is the net of it all. So we've looked at size. We put man in the middle. On the large size, we discovered the universe is finite in the macrocosm. On the small size, quantum physics, subatomic particles, it's finite, limited in the smallness, macrocosm. So if we take the whole thing, we discover that we and the universe we are in are really finite and simply a digital simulation made up of finite units. Nothing's analog, everything is digital. The boundaries of our reality, the metacosm, our universe is but a shadow of a larger reality. The more you know about advanced science, the more conversant you are with the frontiers of science. If you can pick up The Road to Reality by Roger Penrose or books of that level, the more you know about the frontiers of science, the more comfortable Genesis chapter 1 reads. In our commentary of Genesis, we spend a full hour on each day discussing the technologies that are implied. How would you like to take a physics course with 1950 textbooks? Or 1970 textbooks? Or 1990 textbooks? Hardly. You'd be laughed at because they're constantly changing.